Alright, our third lesson is on correlated, or what we call co-function identities, that should say. And identities are basically a different way of writing different trig functions. So in grade 11 you would have studied two trig identities. They were the tan identity, so tan of theta is equal to or equivalent to the sine of theta over the cos of theta. That was the tan identity, and you also had the Pythagorean identity, which was sine squared plus cos squared theta is equal to 1. And you could write that in different ways. You could write that as cos squared theta is equivalent to 1 minus sine squared theta, and you could do the same thing by rearranging sine squared theta to be 1 minus cos squared. And at any time when you were solving identities, you could substitute left side in for right side at any point. Well, we're going to continue working with identities, and we're going to, today we're going to work on discovering 12 more. So let's get started. The first thing is correlated or cofunction really means two parts. And by two parts, we'll see very quickly how that comes into play. So there's a set of instructions here that we'd like you to do. And the first thing is to sketch a right angle triangle, labeling it as I have here. The angle X is located in the bottom left-hand corner by A, and the right angle triangle is located at B. The first thing we'd like to do is just represent or just state the trig ratios of sine, cos, and tan. So looking at the triangle through the eyes of X, we notice this is the opposite side. Here is the adjacent side, and of course this is the hypotenuse side. So sine of X is going to equal to opposite over hypotenuse. I'm going to use the small lowercase a over lowercase b as a ratio. And I'm going to continue the same thing for cos of X, which is c divided by b, and finally tan of X, which is opposite over adjacent, a over c. That part's fairly routine, and now what we want to do is we want to look at the triangle through the eyes of the third angle that's unlabeled. And we're going to look at the triangle through the eyes of angle C, but we're not going to call it angle C. We're going to represent it with the two angles that are provided for us. So we know that the sum of all three angles in a triangle equal 180 degrees. We've used up 90 already. So I have this angle here of X, and I have this angle C. So another way to write angle C is really, because we've used up 90, we only have 90 left. And if this is X, then this should be pi over 2, which really is 90 degrees, subtract X. And so we are going to represent sine of pi over 2 minus X as a trig ratio. Well, we know that when we're looking at the triangle through the eyes of pi over 2 minus X, this now becomes the opposite side, and this becomes the adjacent side. The hypotenuse stays as is. And then we just repeat. Opposite over hypotenuse is c over b. The cos of pi over 2 minus x is equivalent to a over b. And finally, the tan of pi over 2 minus x is equivalent to c over a, opposite over adjacent. So that's the first part of setting this up. Now, we haven't really defined any identities yet. That's going to be our next step. And the next step is to recognize that the ratio of a over b appears over here as well. So because these are the same a over b, we can set cos of pi over 2 minus x, there's the co part, two parts, equivalent to the sine of x. So here is our first identity. Cos of pi over 2 minus x is equivalent to sine of x. We notice that we have a c over b here, and we also have a c over b here. So we're going to write the sine of pi over 2 subtract x is equal to the cos of x. And then finally, we take a look expecting to see an A over C and an A over C here, but we don't. So this is a little bit of a special case, but we can figure out fairly quickly because we notice that this is really just the reciprocal of what I see over here. So tan of pi over 2 isn't equivalent to tan x, it's equivalent to the reciprocal of tan x, which of course is cotangent x. So here are our first three new trig identities. These are called correlated or cofunction. We also have the reciprocals of all of these. And the reciprocals of these is cos is secant pi over 2 subtract x, and the reciprocal of sine is cosecant x. The reciprocal of sine is cosecant, so you can see what we're doing here. We're just replacing all of the primary trig ratios with their reciprocals. And finally we get down to cotangent of pi over 2 minus x, and we remember the reciprocal of cotangent is going back to tan x. Now there's a couple of important points we should note. You'll notice that cos and sine are always paired up, and tangent and cotangent are always paired up. Now all of these angles are dealing with when x is an acute angle. That's very, very important. So when x is between 0 and 90 degrees, this will always occur in quadrant 1. So now think of the triangle that we drew as any angle within quadrant 1. And this holds true. Think for a moment of the cast rule. The cast rule says that in this quadrant, all three primary trig ratios should be equal to positive answers, and they are. There's no negative signs in here. That holds true for the reciprocals. There are 6 new trig identities. There is patterning here. Notice the secant and cosecant, cosecant, so secant. So just like we have cos and sine in both of these, we have their reciprocals, and the same thing for cotangent and tangent. What we're going to do next is we're going to move to quadrant 2 and take a look at 6 more of these correlated angles. And we're going to do this in a slightly different manner. The first thing we're going to do is we're just going to show a method of making sure that we get to quadrant 2. And once again, assume that we are talking about acute angles, so where x is 0 to 90. The first thing they want us to do is just to show that we're getting into the second quadrant, is I'm going to label this 30 degrees right here, angle, as P, X, Y. So that means just basically any point. P is a point anywhere in quadrant 1. To get to quadrant 2, if this angle right here is anything between 0 and 90, if I add 90 degrees to it, then that will guarantee that I will get into that second quadrant. So for example, if we're dealing with 30 degrees and I add 90, I'm at 120. That pushes me directly into that second quadrant. So that's the first step. So what we're going to be determining here is when we're dealing with sine of pi over 2 plus x, cos of pi over 2 plus x. Again, these are all putting us into the second quadrant. And then finally the tan of pi over 2 plus x. Now we're not sure at this point what they're equal to, and we're going to do a different method other than drawing triangles. And what we're going to do is we're going to reference our unit circle. We're really going to start to use that. So what we're going to try and do is we're going to try and look at the pattern in the unit circle when we add this crucial 90 degrees. So on the next page I've got a half of a unit circle. So let's focus in on this 30 degrees. So when I add 30 or 90 degrees to 30, I end up at 120. So here is that right angle that we're talking about. So what we want to do is look at the relationship between the coordinate points. Okay, so I know that this is x and this is y in terms of my coordinate points, and the same thing here. But look at what's happening. I have a negative a half here, and in this coordinate point it was the y value. I have in the y value in quadrant 2, I have the same value that's in the x value. So the pattern that's appearing is the values that go into each of the x spots are really the y values from the first quadrant with a negative sign. So we denote that by saying negative y. This is only for the second quadrant. And root 3 over 2 was actually the x value. And we're going to show that this actually occurs and continues to happen. So it's a little difficult to see in 3 pi over 4 only because they're both root 2. But let's just see if this holds true. So this value should have come from the first quadrant of 45 degrees, because that's the 90 now added to it. It should be the y value negative. So it should be negative root 2 over 2. It is negative root 2 over 2. This should be the x value goes into the y position. So it's a lot of kind of moving around. This third example should show exactly what we see. So the y value should be from 60 degrees, because 60 plus 90 brings us to 150. So the x value in the second quadrant should be the negative y value from the first quadrant. So it should be negative root 3 over 2. It is. And it should be the x value placed in the y position. So it's a little confusing, but this is kind of the mapping. What's happening is the y value is going into the x and we're making it negative. And then what we're doing is we're taking the x value and putting it into the y spot. And this only occurs when we add 90 degrees to it. So this is fairly helpful because all of these points, or any point P in the second quadrant, as we saw back here, P prime they called it, these x is really the cos of pi over 2 plus x. Because remember, our coordinate points are always cos and sine. And pi over 2 plus x is going to push us into that second quadrant. So we're going to use that same relationship. So let's do cos first. According to our mapping, and the mapping's revealed for us here, the x value in the second quadrant should be the negative y value. Well, let's go back to what we have here. Well, normally this is just simply cos x, comma, let's do this over here. It's normally cos x sine x. Those are the coordinates in the first quadrant. So let's just write those out. Well, this value then should be the y value but negative. So cos x pi over 2 plus x should be negative the y value from the first coordinate. Sine, which is the second value, should be the x value, just simply cos of x. And tan, well, think of your identity. Tan is equal to sine over cos. So the sine value is cos x, and the cos value is negative sine x. And that simplifies to become negative cotangent x. So that was fairly quick. So you may want to pause and rewind this video and watch that again to see what happens. But here's a couple other things before you do that to make sure. According to cast rule, C-A-S-T, the only trig function that should be positive in the second quadrant is sine. So let's find sine. There it is. The value here is positive. The other two are negative, so that checks out. Pi over 2 places us in the second quadrant. Again, do we have that combination of sine, cos, cosine? We do. Do we have tan, cotangent? We do. So when we're writing out the reciprocal functions, those would continue as well. This would be cosecant, pi over 2 plus x, equals secant x. Secant, pi over 2 plus x, equals negative cosecant x, and so on. So all of a sudden now, we've generated the 6 from the first quadrant, the 6 from the second quadrant. We've got 12. There are 6 more down here, and 6 more down here in quadrants 3 and 4. And the procedure, the process still continues to be the same. So on this page, I've written down for you the correlated or cofunction angles, only the primary. So I'm hoping that you can write out the reciprocal functions. Make sure you check those with your teacher to see that they are correct. And then take a look what's happening down here. We're not going to actually take a look at the proofs, but it is, again, using the unit circle, taking a look at these, establishing the pattern. But you'll notice that they use 3 pi over 2 instead of pi over 2. The reason they do that is we use the 90 degree or the pi over 2 in the first two quadrants, and now we're using 270 degrees or 3 pi over 2. So this is saying if this is an acute angle, if you take away a number between 0 and 90, you will end up in quadrant 3. If you add a number between 0 and 90, you will end up in quadrant 4. And remember the cast rule. That's something that should always follow true. So adding these up, we have 24 primary plus the reciprocals, which aren't written, new trig identities. And we can use these whenever we want in order to solve questions, and we will do some of those later on. So that takes care of a lesson on what we call equivalent trig expressions or correlated angles. We will be looking at compound angles and related angles soon.